Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're really excited to introduce to you the newest member of the TI-Nspire technology family, the TI-Nspire CX II. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Tonight, we're really lucky to be joined by our two panelists, John Hanna and Sean Bird. John's a teacher from Hopatcong, New Jersey. He taught mathematics and computer science for 35 years at Teaneck, New Jersey High School. And since 1993, John's been a T-Cube national instructor and has been honored with the Radio Shack National Teacher Award, as well as the T-Cubed Leadership Award. John now enjoys teaching teachers and traveling around the United States, discovering that we're not all that different. John, thanks so much for joining us tonight.
Thanks for having me here, Mike.
And Sean teaches AP Calculus, Physics, Intro to Engineering, and over the years has taught many other math and science classes at Covenant Christian High School in Indianapolis since 1996. For the past 20 years, he has instructed teachers in the effective use of the TI-ID 384, TI-89, TI-Nspire, and TI-Nspire Navigator system, as well as the TI Innovator. He's a father of a mere 7 children, and he enjoys making learning fun and hands-on. Sean, thanks so much for joining us tonight.
Oh, it's great to be here.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send any questions to Sean or John using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link, the event certificate of attendance, at the conclusion of the event. We'll also be providing a link for the documents that John and Sean are using tonight. We hope you don't have any audio issues, but in the event that you do, try selecting Communicate from the very top of the WebEx menu and choose Audio Broadcast. At this point, Sean is going to discuss our agenda.
Yes, so we're in the middle of the welcome and introductions, and very excited to share with you what's new with the TI-Nspire CX II, and as well as the premium teacher software. And then stay tuned to the end because you must be present to win. There's going to be a drawing for summer workshop registration, so free registration.
Thanks so much, Sean. And John's going to discuss our expected outcomes.
And there's a lot of stuff that's new in this CX2 platform, but we are going to try to emphasize what's going to make a difference in your classroom the most. There's a lot of good stuff going on in both the premium software and the handheld itself. I'll pass it on to Sean so that we can get started.
Thanks so much, John. Sean, you have control. Feel free to share your screen.
Coming right up. All right. So, yeah, back in 2011, the TI-Nspire CX came out, and now we're ready for 2. Back then, okay, I accidentally turned on annotating. Please stop. Good. So let's cue up the little opening PowerPoint, and away with the show. So, what's new with the TI-Nspire CX II? Yes. So, to begin with, there is a new processor. Why is it called 2? Besides, I don't know. Well, it is over 2 times faster. The processor is, like I heard, 2.5 times quicker. So those things, the operations that you were doing, that you're like, wow, this took a little while, which is probably pretty rare, especially if you're used to other graphing calculators. Now happens a lot quicker. Also, there's some new color, as you can see on the CX2 has a white faceplate, or white face, and then a blue cover, whereas the CX2 has the blue back and side, and then there's that school edition. The updating of the fonts and icons, improved performance, simpler user interface. And then regarding the desktop premium software, I look forward to showing you, jumping out of this PowerPoint and showing you how the navigator is now included. And then, for example, you can have a live presenter for any connected handheld. Even if you don't have the wireless navigator system, you can enjoy some of the beautiful features that are on that. So so here comes the rest of the overview of what else we're going to see here tonight. The math features, including disabling CAS, multiple tick mark labels, graph labels. There's some improved slider experience that I look forward to showing you. Point by coordinates, animated path plot. There's some real teaching possibilities with that. And then and then John will show us some fun things with the programming. There's new draw commands for graphics programming, auto indent, and better error messages. Okay, so like I said, let's get on to out of this PowerPoint. Just in though is the CX2 CAS is allowed on the IB exam. So similar to how it's been, the ACT for the CX. CX2 now, and for the CX2 CAS you can use it on the SAT, AP exams, PSAT, and on and on. Okay, so let's get down to business. Here we go. So I guess I told you I was going to show you a little nav feature. So if you notice down at the bottom left, I have 0 clients connected. I'm just going to plug in my TI-Nspire that is plugged in, and here in just a moment you'll see that I have 1 client connected. So what could I do with that? Well, from my from the over here in the content tab, and I see this 1 guy connected, and I could make that 1 guy the live presenter, and we can see what is on the student's handheld. Well, this is fun. Look at all those neat graphs. Oh, this must be a CAS, because the CAS you can have pi over 2 and pi, 3 pi over 2, and I can. So this is one of the things I enjoy in my classroom all the time with the navigator, as well as sending them files quite quickly. For example, if I wanted to send, guess that class has to be started. Let's go to the fun class, where I just have students' names of A, B, C, D, etc. So if this person over here were to log in, then I could just send a file that I'm working on real quickly and easily. So 5 to log in, AAA tab. All right. So you can see that actually going on here in the back, and all I got to do is send it to the class. And how about, yeah, just send it to everybody, finish. So now if somebody else were to come in and plug in, then they would be connected, and they could just start working with the fun file that I just sent. All right, so enough Navigator for now. We could spend a whole workshop teaching you about the great features of the Navigator. So let's talk about something that works for everybody. If you update the operating system for the TI-Nspire CX or the CX CAS, then we'll enjoy these mode settings that so easy to change from radians to degrees. So I shared this with my class, and they definitely got excited when all they have to do is press where it says rad up here, and then everything on that page is going to change to degrees. You can see the graph in the bottom left, pi over 2 right there, and if I click right there, it's so fast and easy to enjoy having it in whatever kind of angle measurement you need to have it in, especially since I teach both physics and calculus. Then I have students who want to go back and forth from either one. All right, so how about the disable CAS feature? So obviously this is only if you have CAS. If you're trying to do this without a CAS, then you're like, well, why doesn't it have that feature on mine? So if you were to go to doc and the settings and status, and how about the document settings, then you would see here that there's a CAS mode, and of course it's on because I'm enjoying using CAS for teaching and exploring. And if you want to learn more about CAS, there's a USA CAS conference this summer up in Chicago. So we could turn it to off or exact arithmetic. So let's turn CAS off and see what happens on the next page. Okay, when I said next page, I meant over here, this page right here. Yeah, so it says error, CAS computations are restricted. The biggest thing about this is for press to test. If you put your class in press to test, then they could have CAS turned off. And so let's turn CAS back on. And you can do that from the home screen. There's settings, and then under the document settings, there's the CAS. Let's turn it back on and see what fun things are happening on this page. Okay, when I said this page, I'm going to go back to my current document, number 4. And, okay, well, let's do that here. Document settings, and CAS is off. And we said, no, thank you, please, CAS is on. Okay. And so if we said, hey, do those again, okay, good, we just had to turn back on. So this is a notes page, and I really think that doing operations in a notes page is quite valuable. For example, you can see a little slider set up on this notes page. Sliders on notes pages have been around for a year or so. But, oh, isn't that beautiful? That's fun. Yay, CAS. Way to be able to explore all kinds of neat things. Okay, so if there's, got one more to show you before John starts telling us about some of the features. So we did the disable CAS, and so one other thing was about DE solve. So there's now a wizard for the DE solve. DE solve wizard. Let's take a look. So if you were in calculus and you were doing differential equations, and you're like, okay, I don't teach calculus, so all I have is algebra students. Well, hang in there just for one moment, because you're going to find something that's actually of great value, of pedagogical use. Instead of getting lost in the syntax, if we were to press menu, calculus, and again, you can tell that this is the CAS feature because I have a few more options under here. There's a differential equation solver. Note the ... That means good times happen after you make that selection. So we choose that, and we were going to do y prime. Tips for where the prime is yes, it's under punctuation. Also under pi, and yeah, you could click pi, or probably just back arrow once is a great plan. And like I said, it is under punctuation as well. So y prime is equal to x over y, and the independent variable. See, I told you this was valuable for algebra students. So which one is the independent variable? And the dependent variable? And we do have the option of putting in an initial condition. So let's put in the initial condition of 3. When x is 0, then the y is 3. Boom. There it is, ready to press enter. And then we see a nice answer, which actually was probably shown using, I believe I have it set for Euler's method to get that on the previous page. Okay. So now, look forward to hearing what John's going to share with you over here.
There's the graphing features have 2 additional really cool features built into it. One you saw earlier when Sean showed you a graph screen. So the show all tick mark labels is now an attribute of a graph page. Switch to the next page, Sean. Notice the ones near the origin. And wouldn't we like to see more of those numbers across the x and the y, up the axis and across the y-axis, up the y-axis and across the x-axis? So if you right-click the axes, select Attributes, and on the Attributes list, scroll down to Single tick mark labels are shown. Notice that it says 2/3 in front of that tip. To the left is multiple tick mark labels are shown, and all the tick marks are now labeled with numbers. If you press enter, then it'll keep those settings. Now, Sean had some nice trig expressions on his screen before. So if Sean clicks on the 1 on the x-axis, the number 1, and type pi over 2, just use the word pi, divide by 2.
Since I'm using my software, I'll just type pi.
Now you notice that we only see 2 tick mark labels again. So Sean, grab the x-axis tick mark label and pull it outward, away from the origin. And why don't we see the rest of them? There they go.
One thing I think it has to do with is perhaps if I change this one.
Change the Y one as well. If the tick mark labels get too close together, the software developers have decided not to show them. So when the tick marks are too close together to make a pleasing appearance, the tick mark labels will all disappear except for the 2 main ones. Those 2 that are closest to the origin are the ones that are clickable and editable. The rest of them are there just for show. On the same token, look at my agenda again. Let's graph a function on this page.
Okay.
Double click anywhere.
I'll be right there. One thing, when you did multiple labels, it gave the message a little warning, adjust windows if not shown. So we are here, and if it's not working, then we just need to adjust the windows. All right, so ready for the graph that you had queued up in F1 or something else? Or you were saying?
Let's try this one.
Okay.
Nope, you pressed enter, didn't you?
No, not yet. Oh, try the one that you've got?
Try that one.
Okay, excellent.
Okay.
No,
go up and just retype it. The whole thing.
Okay. I thought it worked before. A times.
Yeah, it only works once.
Yeah, plus bx. Oh, b times x. That's super important. B times x plus c. And all right.
Do another one.
You know what I'm going to do? I'm going to do this little trick called, since we had it queued up and I think I maybe tested it out and it worked beautifully last time, then this is called number 1. And here we go. So when I come over here and I up arrow to it and I press enter, okay, nope. So I'm just going to try a times x squared plus b times x plus c. I get this. Haha, there it is. That's what we were expecting.
Right. Okay.
So this has been around for a while, but boy, it sure is a friendly way to put sliders on there.
Now, each of those sliders is usable.
Wow, this is nice. I like how dirty your F1 showed up.
Yeah.
That's cute.
And they all use oh, that's even better. Both functions are showing now.
Really?
I haven't seen that before, really. But it shows what I was going to demonstrate with this one, too.
Yep.
That F1 of x shows the numbers in the expression, and F2 of x shows the letters. They're both the same function, and they're both controlled by these sliders. So you're seeing the same function twice. To get those numbers to appear in an equation, you right-click on the graph.
So if we were to right-click on the red graph, right-click is known as Control Menu when you're on the handhelds. Let's see if I can move my little cursor over there and a Control Menu. And okay, no, I did not succeed. I'm currently have this selected. So we want to have this selected and hovering over the contextual menu. All right, Control Menu. Keep going, John.
Go to Attributes. And if you scroll down the attributes to the letter A, label parameters show names. And if you hit the right arrow key, show values. So you can switch between the letters in the equation and the values of the letters in the equation through the attributes. You may have seen a lot of old math-inspired activities which look like this with the numbers showing in the equations, but it was really hard to do.
Yes.
And now it's already built into the software. Teachers talk, TI listens.
Yeah, so nice.
Tick mark labels and dynamic functions. All right, Sean is going to do something with dynamic points. This is a new feature because we always want to put a point on this graph somewhere.
So if you just press the letter P, then you get some options. You get points or points by coordinate. And one of the incredibly powerful things, no, choose point by coordinate. And so, John, if we wanted to put that point on the vertex, what would we need to do?
What's the x-coordinate of the vertex of ax squared plus bx plus c? And if you work through the algebra, you'll find the vertex is negative b divided by 2a. And you can type that expression in for the x-coordinate.
Negative b all over 2a.
That's wrong.
You are correct. How about we use the handy control divided by and all over 2a for real? How's
That's
that?
right.
Excellent. And to get over to the other side, press Enter, and then now we're here in the y-coordinate.
So what's the y-coordinate going to be? Well, we could try F1 or F2.
Nice. Yes, exactly. In this case,
of negative b over 2a.
F1 of the same thing, of the negative b all over, I'll use parentheses, 2a. And how about Enter? Yeah, oh, there it is. Look at that point. Maybe I'll make this point real big, so people can see it from far away, all over the world. Whoa, that's super big. How about medium-sized big? And maybe that is do a little color. I'm right-clicking and changing color around. How about, yeah, there. I'll check. We'll stay with that. Isn't that neat, this point, when we go to this point, which would stay close to it if we left it close, it tells you that is negative b all over 2a, and it puts enough parentheses in there for you.
And it remembers those expressions.
So students can explore as they, that's interesting. Look at that as we move the b around, and
can we see the path of that point somehow?
Well, there's that nice right click that we talked about, but and notice there's a thing called geometry trace. I bet you we could just do geometry trace to the menu, because that's how you do things. If you ever want to do something on the Inspire, you can probably find it under menu. And hey, look, you can only be wrong like 8 times, and then you're going to be right on the 9th time. Oh, how about trace? And this is a nice segue into where we're heading next, because geometry trace is down here, number 5, but there's something interesting that we'll see a little bit later on for that path plot. So yes, there's found the geometry trace. Oh, and it tells you forget how to use it. Click the object to trace, and then manipulate the object to leave a trace. And you can get rid of that mess by erase geometry trace. But this isn't going to be a mess. This is going to be beautiful. Click, and oh, one of the beautiful things I love about sliders is you can just use tab to get to the next slider. Or I went too far. I went this B slider, and so I'm on B. I'm going to press Enter, and then I could just use the left and right. Okay, click and use the left and right. Okay, geometry trace. Leave your trail. Oh yeah, I got you. There it is. There you go. So you click on it, and then it leaves that. Well, that's interesting, isn't it?
And, so what's the equation of that parabola? But we'll leave that as an exercise.
Yes. Geometry trace has been around for a while. That is not a new feature. I've used it for in my physics class with ellipses, where I have 2 points, and I keep these 2 points, the distance between them constant. Anyway, make an ellipse, and we say, hey, let's see what happens. You know, the kind of thing you used to do with a couple pins in a cardboard and using a string. Now there's still value in that, of course. Yes, the P is brand new. Being able to press P in some white space, escape out of the tool I was using. Yes, pressing P is new, and being able to put a point on something. Excellent. All right, so let's go to show some neat things with the click slider thing. All right. To do this clicking a slider, I've got 2 fascinating things to show you where I'm going to do a new document. All right, so here's a brand new document. Let's take a look at a graph. Now, we already showed you about sine of a times x. Make sure you put a time sign between those, because it can understand an ax. It knows what an x is. Well, it's a variable to it. Okay, so here's sine of a times x. And would I like to create a slider for a? Absolutely. So here's this nice little slider. And remember how easy it is with the latest operating system to change it to degrees. So here it is in degrees, and you're like, well, that's not so helpful or interesting. Right, I hear you. So I'm going to modify my slider a little bit before I do my next crazy thing. So I'm going to go to, I right-clicked on it, Control Menu on the handheld, change the settings. I want to go from, how about 0 to 90? So I was looking for interesting things to do. How did the grid show up automatically? Well, that's a nice new feature with the CX2. If you'd been using grids before, then it's just going to remember that you like to have grids. And so no longer do we have to go to Menu, View, and the grid and say, yeah, I want the line grid. That's what's already selected. And so you don't have to go there each time. It's just default to stay on there. If you had been using it before, then it's going to stay there. Okay, so here's this new clicking a slider instead of having to do a lot of other steps. Now, if I were to come up with a rotation tool, so menu, geometry, and I wanted to do some sort of transformation like a rotation, then you want to click. Yeah, I do want to do the x-axis. I just want, sure, that right there. And then I'm going to click this for rotating it. Click. Yeah, so there it is. It left this, I think, yeah, it left this line. You can't see it too well, but I believe I was successful in doing it. And now, we'll do this trick about to activate the slider on this page. Tab, Enter, and then I can just use the arrows. So watch this. Isn't this interesting? I get up to, oh, hey, little point. I wanted you over here. Redefine my point. Put him right there. There he goes. So I wanted this point right there. So watch this. When I move this along, isn't that interesting? I don't know if that's too useful. Let me show you one that's maybe even more. I thought that was mathematically fascinating, how it seems to like line up with it now when it's in degrees, and I'm changing it to 90 degrees. Okay, well, to see one more example, I'm going to do this geometry page. That's one of the things I love about the Nspire. It's a tool that can be used in all the math classes very, very easily. All right, so let's insert a slider. While I'm going to Menu, Action, and Insert a Slider, this is something that's been around on the software, MathDraw. I'm not going to demonstrate it because it's not a new feature, but I wanted to point it out that it exists. It's really fun to do and explore on the software. So here's an insert slider, and as we're inserting a slider, I'm just going to call this rotation, and let's go from 0 to 360, a step of 1. So let's see what happens. If I were to put a little circle or triangle, menu, and shape. If I were to put a little triangle on here, there's a triangle, and then I wanted to do some sort of transforming it, like how about a rotation? All right, so let's see, if I click on that and then I click rotation and I click right here, oh look, it's rotated like 1 degree. See how easy it is to use this little slider that's already there. And so I'll escape out of that tool and watch it turn. Isn't that fun? And so easy to use. So put a slider on there and try clicking it to make crazy cool things happen. All right.
Just let me follow up with that a second.
Absolutely.
The important step that he kind of glided over quickly was that he clicked on the slider for the angle of rotation. So he clicked the triangle, then the point of rotation, and then the slider becomes the angle of rotation. In the old ways, you had to draw an angle to make the angle of rotation. Go ahead, Sean.
Excellent. So click, and pick a point for it to rotate about. Whoa, that point right there. Maybe. Okay, so escape. All right, back to what's new with 5.0. So I'm going to jump to a different section of this. We are going to, okay, let's talk about path plot. Um, how are we doing on time? Yes, because
Halfway there.
John could show you all kinds of amazing things. All right, for functions, um, you could use it as a teaching tool, but I highly recommend having it set up before the students arrive. Okay, if the students arrive to class and you've already got this, then it's not as meaningful as if I were to, I've already pressed menu trace, and we'll do it several times, path plot function. All right, so then you can have students predict, okay, what's going to happen if we move over. In fact, they can test out their little math skills and put a negative 10 into this into the blue one, and of course you put negative 10 in there, then you would get yes negative 5, and then here's some fun with fractions, and so where will these two ever intersect, and why do you think they'll intersect? So and then you can right arrow, and we can see the values changing.
Sean is pressing the right arrow key right now.
And we think that they're getting closer together. And what value will they intersect? And, well, there it is at negative 4. When you put negative 4 into this, do some math, then you would guess you'd get negative 2. And we could ask other fun questions like, okay, who thinks they're going to intersect again ever? And hopefully students are learning things about lines and like, oh, no, they're never going to intersect again.
That's
yes,
the left arrow key at work.
Yep, left arrow key. And yes, we can press the play, and they'll start going at their own little pace of animating. Another tip is you can use the up or down arrow, and it'll show that was up, as you can see over here in the red on the side, to see where it's going to go. It projects the path, and so reset it back to the beginning. And there was that left arrow, or sorry, up and down, or just keep going up, and it'll show up or not show up.
So look at the plot setup menu, Sean.
What's that?
Look at the plot setup menu.
Yes, one of my next examples will show some of that.
Okay.
Wanted to point out some other things for parametric and for polar. This is a great exploration tool, a way for students to discover things. But for functions, I highly recommend having it set up on the screen for when the students come in, and then the kind of questions that could be asked for discovery are on here. And this file will be available for you when this is posted. Is that right, Michael? Mr. Houston?
It sure is.
Yep. All right. So.
Hey, also, Sean, real quick while I'm unmuted, can we just review real quick, if it's easy to do, the features that, for the most part, you've been sharing tonight? Is that strictly a CX2 feature, or is that an operating system feature? So whenever the new OS is released, if someone has a non-CX2, will they be able to update to, say, 5 point whatever?
So you can only go to 5.0 with the CX2 handhelds, or with the teacher software. So teachers that are using the software, yes, can have all of these features on the premium software. And so there's that the premium software that can get all those new features. So no, if you have a TI-Nspire CX, then the biggest thing you'll get to enjoy is the degrees in radians. The other features are coming, and from what I understand, the price is pretty much the same as and it depends on the dealer or something, but the price is pretty much the same as the CX. The CX2 will be pretty much the same price. And for one of the places I saw the difference between a CX to the numeric Nspire as versus the CAS was only a $2 difference. And so, hey, since you can disable CAS for $2 more, wow, so much power. So we're going to take a look at the path plot So besides function, parametric, polar, there is the setup of that path plot. And so we can here we can choose how big of a step it takes. So we could say, hey, let's make it always be a 0.5 step. And then you could also choose whether or not you want to change your mind. Oh, I didn't want to do function. I want to do. Oh, that's pretty fun. When you do things like polar or parametric, making the step size something multiple of pi, as in pi over 12 or pi over 24, that can be a great idea. So for function, we were going to be 0.5. Okay. And so if you menu trace path plot, let's do this function. And so then we could arrow to the right, and you're like, I don't see anything. That is correct, because G is showing up down here at -8, whereas this parabola is up there at +28. So soon we might see something like when they get inside this viewing window. Oh, there's that one. And so again, the kind of questions like, do they intersect? How often do they intersect? Where would they intersect? Oh, how about there's one spot? And based on the concavity, I think they'll intersect again in this viewing window. And the other one is, boom, right there at 4,4. And to recap one more time of something John was showing us, if we do choose right-click attributes, oh, you know what? If instead of right-click, how about you do menu actions? And there's attributes. Told you everything's under menu. So then you could pick which thing you want to do the attributes. And we could say, hey, I would like it to show what that value is for B. Make it more transparent for the students to be able to see that connection. Okay.
So just a comment about the path plot is that it can only do one function type at a time. You can either do function or parametric or polar. You can't mix parametric and polar and function all in a same path plot. But keep in mind that all functions can be written as parametrics. And it gives new reason to the study of parametrics if you want to do more interesting polar and function intersections.
So for example, hey, here's a parabola, and here's just a nice horizontal line. And yes, they are done in parametric. And so a question I might ask students is, do these intersect? And everybody's like, yeah, definitely. Look, they intersect right there. Okay, well, hold on a second. Let me back this up. So here's the situation. A football player is running an impressive 10 meters per second. Down here it shows the conversion into miles per hour, 22.337 miles per hour. And it's passed a football thrown at a reasonable 20 meters per second at an angle of 30 degrees. Explore the graph on the next page. Will the receiver catch the ball? If you want to know what 20 meters per second is like in terms of miles per hour, press enter. There's that. So the next thing down here it talks about is use the trace path plot to be able to discover what happens. Oh, and also there's a link at the bottom of, well, you have to copy and paste it to your browser so you can see more about how this is a very impressive speed and what kind of people can go that fast. All right, so if we were to do the menu, trace, path plot, what kind of path are we plotting on this one? Parametric. So here's the football going up in the air, and it's moving in the x direction at a constant velocity. In the y direction, we have gravity pulling it down at 9.8 meters per second squared, and it was launched at a nice 20 meters per second, and the angle showing the 30 degrees. Oh, it looks like that football is going to get there long before the guy who's running, which makes sense, you know. So, in fact, we could see that this time here is 3.6 when he gets there, but the ball was there back in, how about 2.1? So if we wanted it to be successful at catching, then we would need to do what kind of time difference? How about throw it 1.5 seconds later? So let's see, how good I can be at saying, let's throw it at 1.5 seconds later for the time minus 1.5, and last one, t minus 1.5. Enter. All right, so it still looks fairly similar. Menu, trace, path plot, and parametric. So here it is. He's been running for a good while. So the guy takes off running, and here comes a football. Dun, 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 dun. And victory! Or, you know, at least
touchdown.
With a margin of error. Yes, into the end zone. So we've done it with parametric, and I do have one more amazingly beautiful one queued up to show it with the polar. We did it with parametric, and this is just gorgeous. So do need to be in radians. Check successfully in radians. So here's a planet, and we want to go in orbit, trace, path plot. This is polar. And if we looked at the setup for this, then I think you would okay. Path plot. Menu. Trace. Aim. Path plot. Oh, nope, sorry.
Parametric.
These are parametric. I was like, hey. So no, even though they look very polar, don't they? These polars graphs were translated into parametric. So yeah, I look at this guy and I think polar. Oh yes, but I really do have a powerful polar one queued up with a. Although I started moving things around. Oh, there's this beautiful polar. Look, isn't that nice? So real quick, and then we'll move on to beautiful things with programs. So path plot and yes, polar missed. And you can see how we have the step size pretty small. We have it as in pi over 24. I'll just do 12. Pi over 12. And so 5 for trace, path plot, polar. All right, so doom, 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 boom. There you go. If we made these the same size, one of the things I think that's so powerful is for students to realize that, hey, look at that. In 180 degrees, or in pi, the larger one, the 6 sine of 3 theta, when it's an odd number, then it completes it in half the time as the other one's going to finish it with the 4 petals. And so for students to be able to explore and say, okay, where is it, at what time, being able to do a path plot is really helpful and powerful. Ta-da. Okay, so next up, John and programming.
I go to one slide. I think it's still in there.
File, yep, it is. File number 1.
There we go. And go to the next page. So there are several new features in the program editor. It does automatic indenting. If you type an if statement, then the next few lines would be indented for you automatically. If you select a block of code and you want to put a loop or a while loop or a for loop around it, just select the text first and then paste in the loop or the block. It has better error messages rather than just plain old syntax error. But my favorite part, and I have to admit that I'm a hobby programmer, is this graphics programming capability that's built into the system. So you're going to see a lot. You saw that Mandelbrot set on Sean's slide earlier, and that came from this drawing feature. That's all done with TI Basic and with the graphics tools. Go to the next page, Sean. On the TI code section of TI's website, there's a new Unit 6 on drawing, but it's only for the CX2 platform, not the CX. Go to the next page. Here's a demo program. Notice that there's a stop statement in this program. So Sean's going to run it the way it is right now. Press Control R.
I'm going to use, the Control R. Oh, and I already had demo.
It's on there twice.
So
and press Enter.
If we were over here and we did Control, if we did Control R, then it pops it over to a calculator page, and we press Enter.
So this is a draw line command, and what you're looking at here is a whole new feature of the CX2 line. This is a drawing screen. It's not a separate app. It's just a screen that pops up over the calculator page so that you can do your graphical programming, your drawing. Go back to the program by pressing any key and hit the Control left arrow. And delete the stop command. So the draw line command drew a line from the upper left-hand corner of the screen to the lower right. The default window is 00 is in the upper left, and the screen is 317 by 211. The set window command on the third line down in the program changes it to a regular traditional graphing window, -10 to 10 by -7 to 7. Xmin, Xmax, Ymin, Ymax. So run the program again. Notice that the line is still a diagonal line on the screen. The set window command didn't change anything that was already drawn. And now there's a circle and a rectangle on the screen. The draw circle command draws a circle using the center and the radius. And the draw rectangle command uses the corner of the rectangle and the width and the height of the rectangle. Go back and look at the code. So the draw rectangle command starts at 00 and has a width of 7 and a height of 2. So it starts at the origin, goes to the right 7 and up 2. You get all these commands off of the draw menu. So there's draw line, draw rectangle, draw circle, draw text, draw arc, draw polygon, fill, and a plot point function, plot XY. Select one of those statements off of here, Sean.
How about we fill that circle? Filling the circle.
And then put in the center.
If it's similar to the last one, 005. Yeah, sounds good to me.
And run it.
Control R. Doof. Oh.
And there's a filled circle.
Yes, it is.
Go back to the code. And right in front of the fill circle command, press Enter to leave a space. And use set color.
And we should be able to find the
draw shapes. Control, I'm sorry. And set color.
Notice some other features that are around here, but let's go to set the color.
The funny thing about all of these drawing commands is that they do not use parentheses, and that messes me up all the time. I'm so accustomed to having a parentheses after a command. Let's use 255, comma 0, comma 0.
RGB.
Can you programmers figure out what those numbers mean? If you've used an Innovator before, then you know about the color LED, and it's the same system that's built into the TI-Nspire's drawing tools. Press Control R to run again. And now you have a red circle inside the black circle. Look at file number 2, I think I sent you.
Mm-hmm. This one's fun.
Regular polygons. This one I wrote up just to demonstrate the capability of extending the features that are built into that draw menu. You notice there was no regular polygon function built into the menu. There's a poly command, which draws polygons using 2 lists, and you'll see how that works on the next page. But there's no regular polygon. So scroll down to the bottom of this program. You see the draw poly statement. Draw poly, L1 and L2 are 2 lists, a list of X coordinates and a list of Y coordinates. But what this program does is allow you to enter the center and the radius and the number of vertices, and it'll draw a regular polygon for you.
I like how you use the degree symbol so that it can be in radians and it'll still behave properly for you.
Right. It forces it into degrees. So N is the number of sides. Look at the arguments in the top. N is the number of sides. X and Y are the center. R is the radius. And theta, TH, is the turning angle, the starting angle of the polygon. So press Control R. type in 5, comma 0, comma 0. What's the next one? The radius. This radius is make it 10, and a starting angle of 0. And when you press enter, you see the red polygon is in the upper left-hand corner of the screen because we didn't change the window settings. So 0, 0 is in the upper left-hand corner of the screen.
Mm-hmm.
So make it 50-50 instead of 0, 0.
So cute.
And now we have a pentagon. So the regular extending the functionality is one of the programming ideas that are useful in teaching programming. Go to the next page.
Next page, escape.
And this is the same function, only it fills the polygon instead of draws it. Go to the next page. And this does random polygons. So go to the next page just to show you how this program works, because we're just about out of time. Press enter. Press any key to end. Now, this doesn't show up as well over the webinar because of the latency in the transmission, but each of these polygons is showing up one at a time.
It's showing up great for me. It's so
it
cool.
looks good to Sean. And if you have a CX2 or the premium software, you can download this file and a bunch of other demo programs from my website, which Mike will show you later on. Press escape to stop the program.
Yeah. What about the student who says, "I don't know, I can't find an any key on my"?
Then they're out of luck. And
can we do rainbow and lights out?
Yes, go ahead.
So here's your rainbow program. If we just put whoa, yeah, that's beautiful.
Graphics programming is really easy to do with TI Basic. It's not a replacement for Lua. The last demonstration that Sean's going to show you here is a game called Lights Out. You may have seen this before.
Oh, and here's one of those. I left the error message up there. I like to encourage students to press var. Okay, except for maybe not this time. If they want to find out, or just just up arrow twice to get it and press enter to copy it down. So yeah, I was trying to figure out how to win this earlier and wasn't quite as successful as I would have liked to have been.
So Sean can use the arrow keys here to move the red dot. And when he presses the enter key, it switches that light and it switches its 4 neighbors. The object of the game is to get all the lights off,
yeah,
all the lights on.
I'm turning them on right now, so I would maybe have hopes of turning them all off. Oh.
The funny thing is every game is winnable too.
Oh.
So this is kind of like Lua. If any of you have experienced any Lua coding, this does the same graphics quality as Lua does, except that it's not object-oriented, and it does not respond to the mouse. While this program is running, you can't do anything else on the computer or the handheld because this program has control of everything. And you have to end this program and close that graphics window down by pressing any key in order to get control back on your computer. You can't switch to another page in this document while the program is running. And it's just like any other TI Basic program. If it's running, it's got control of the device. So I think we're down to about 7 minutes left. The Mandelbrot program that you saw earlier, that slide that Sean had on earlier, was one of my latest creations. I learned by looking online how to color the inside of the Mandelbrot set and instead of just getting a plain black interior.
So beautiful.
I was messing around with ways of coloring the interior points as well as the exterior points. Back to you, Sean. I think I've squeezed about as much as I can.
So yes, from what we've heard, the TI-Nspire CX II will be available from distributors in late April, and So I have a classroom of students who have the TI-Nspire CX. I'm using the premium software. Actually, I've got one handheld, so I've been enjoying like the first student who gets a class gets to grab the blue TI-Nspire CX II CAS and enjoy the speed of it. It's actually very true. I have the student who comes in like, I'm getting the blue one. And yes, it is important to update if you're going to have a mixed classroom with your navigator. To update to the 4.5.1, and so that we can easily transfer files between CX2 and the CX. Now, of course, those features that are only for the CX2, like what we're playing with here, the graphing capabilities, the draw feature on programs, then you'll just get a message like, that's for the CX2, and and so I think we're back to Mike. Again, the beautiful thing is you can, under Window, if you're like, hey, where's the navigator you told me about? It's right there under Window. You can disable, I could turn it off, or you can enable the TI-Nspire CX Navigator. And I will look to stop sharing, unless there's any questions or something I should show.
Just, I think, one question I just saw pop up from Scott. Is the premium software for CX2 available currently or not until late April?
The premium software doesn't seem to be on the website. It'll be available, yes, I think, from what I understand, coming up in late April. So yeah, they listened to a lot of requests from teachers, and so there it is.
And it helps to call 800 TI Cares.
Yes, definitely good tip.
Back to Mike.
Thanks, guys. As we begin wrapping things up tonight, if you have any last-minute questions for Sean or John, please try to get those asked. I know they'll do their best to get them answered. Being that this is, again, brand new hardware and software, there may be a lot of questions that we don't know all the answers to yet, but we're going to do our best to get those questions answered soon. And I think once everything is released, come late April, June-ish, or May, I think things will be a little bit clearer. So hang tight. Really excited that we have a bunch of T-Cube summer workshops that are coming to an area near you. These workshops will let you focus on different content areas or pieces of technology that you'd like to receive more training on. It's also a great way to spend some time with other people that are like-minded. So we hope you will join us at T-Cube Summer Workshop. You can learn more information about locations and offerings on our website. As Sean mentioned earlier, one lucky winner tonight is going to receive a free T-Cube Summer Workshop registration. And tonight's lucky winner is Daniel Haslauer. So Daniel, congratulations. We'd see you as well as everyone else at T-Cube Summer Workshop, and we'll be in touch over email in a couple days to give you a little more information. To receive a certificate of attendance for tonight, go ahead and click the link in the chat window. Also listed the link for the documents that were used by Sean and John tonight. And I noticed that John also posted a link for USA CAS as well. Please follow that link to learn a little more about what USA CAS is and where it is and when it's coming. And if you're watching this on demand, go ahead and copy that link to your favorite browser to receive your certificate. And if for any reason the link or links aren't working tonight for the certificate of the documents, hang tight. In a couple days, you'll automatically get a follow-up email. And in that follow-up email will be a link to the recording, a link to the certificate, as well as a link for the documents. And as John mentioned, I just want to reiterate, any last-minute questions that happen after the webinar, feel free to give us a call at 1-800-TI-CARES or send us an email at ti-cares@ti.com. We'd love to hear from you. thanks so much, Sean and John, for everything you shared tonight. It's really exciting to see some of these new features, and even more exciting to think about how those new features are going to help my students in their math and science classrooms. So thanks so much for everything. And thanks so much for everyone for joining us tonight. We hope to see you back online real soon. Have a great night.